If this is actually your first time of seeing these videos, we define automatic changeover to be a device that switches in between two sources of power, probably from your NEPA to your gen or your PSCN to your gen. What we want to do now is actually to be an automatic changeover that can switch off our generator. So what we want to add now is just a little. So if you have not actually gone through how to build an automatic changeover using two contactors, please go back to the video or click on the link. Now, the normal principle on how generator turns off is when you touch the neutral with the earth, the generator goes off. Most of us have actually engaged with listers before. We know that most of these are olden, some of these are olden listers that the switch has been probably mishandled or is spoiled or whatsoever. You usually notice that for you to turn the generator off, you have to take a wire and place it on the body of the generator or the lister for the generator to go off. The same principle is actually what we are using to turn every of the generator you are actually seeing off, and it's not an exception. So what happens here is that controversially, away from what we thought that if you want to turn something on, you press it on. If you want to turn something off, you press it up. That's not how a generator works. Now, for you to turn off a generator, you need to make the contacts to touch each other. Meaning the same thing we actually see in our olden days listers. So for you to turn on a generator, you need to make sure that their contact is open. Let me come again. Away from what we actually thought about switching on and switching off something. For you to turn on a generator, you need to make sure that the contact of the switch is open for it to be on. Then for you to turn it off, you need to make sure that the contact of the switch is closed for it to be turned off. And that's basically how we used to turn off our generators. So from the automatic changeover that we've already done, which is an automatic changeover that can switch in between two sources of power using two contactors. We have other contacts. Even if we don't have contacts, we have what we call an auxiliary contact. So this is what we call an auxiliary contact. If, for example, that you are faced with you are faced with a contactor that doesn't have you are faced with a contactor that doesn't have normally open and normally closed. What we normally do is actually to get this auxiliary contact to help us achieve other functions, probably functions that doesn't require higher load to carry. We have to add this auxiliary contact to be able to achieve that. So auxiliary contact helps us to actually achieve other functions when our contactor is limited. Most people can actually go for this contactor. We used to call it multi-terminal contactors. These multi-terminal contactors has other contacts that are normally open and normally closed, which will help make you not to require this auxiliary contact. So if you are using this, you will not be needing this. But if you don't have this, that doesn't mean you cannot achieve those functions. You can as well get this. So what we do is on the contactor one, where we already have the utility supply coming in, that's what we use to turn off our generator. Because what we want to achieve is that when power comes in, it switches off our generator so as to allow the NEPA go in. Let me come again. What we want to achieve is that whenever power comes in, it turns off our generator so that utility supply can go directly to our load. That's the reason why we introduce the auxiliary contact to the contactor one, which is this. So now look at the diagram on how to turn it off. The reason why we make it this way is that you can manually turn off your generator and it can automatically be turned off as well. That is why our cables are being connected in parallel. Let me come again. The reason why our cables are being connected in parallel is that the automatic changeover can turn off itself, probably if a utility supply comes on, or probably if you are no more need the generator to be on, probably from the comfort of your home or probably from the comfort of your bedside. You can as well engage this switch for this generator to turn off. So when we add this, watch very closely, 13 and 14, we can find it here. We can replace this 13 and 14 with LO1, LO3 and T3. This 13 and 14 contact we are seeing, we can add it to LO1 and LO3 of the contactor 1, and we are still going to achieve that purpose. Why? Because for 13 and 14 are the normally open contacts of any contactor. 13 and 14 is actually the normally open contact of any contactor. So we can as well use that to achieve it. So having said that, let's go down to business. Okay, coming here, we can see that this is an automatic changeover that can switch in between two sources of power. So the reason why the NEPA is not energizing anything here, or the utility supply is not energizing anything here, is because this contactor is opening the circuit. So when I close it, you can see it has closed it. So what happens is that when we introduce our gen, look at what happened. You see, it comes on. When our utility supply comes on, it takes the generator off as well. When our utility supply goes off, the generator goes back to power our building. This thing happens in milliseconds, just like you can see it. And hardly will you notice a flicker in your light bulb. Hardly will you notice a flicker in your light bulb. That's actually how this works in milliseconds. So look at it. When NEPA comes in, this guy goes off. When NEPA goes off, this one comes in, provided that the power is still intact. So what we now did for us to be able to turn off our generator when NEPA comes in, let me show us. We now connected our cable to normally open contact of the contactor one, which is this one. Why did we do that? The normally open means that when the coil terminal of the contactor is not being energized, that the circuit is open. So when the coil terminal of this contactor is being energized, that means the circuit is now closed. Let me come again. What it means is that when the coil terminal of this contactor is not energized, this 13 and 14 is normally open, meaning that if you use your digital multimeter to read the continuity, it's not going to pass. But when the coil terminal of this contactor is being energized, this normally open automatically turns to normally close. So that's the reason why we connect our cables to 13 and 14. So what happens using the illustration I've actually gave us at the board is that when we connect this, let me show you something. Okay. So what happens, as you can see, is that we have connected our wire to normally open contact of this contactor. Okay, what we can see now is that we have connected our wire to 13 and 14 of contactor 1, 13 and 14 of contactor 1. So what's the principle there, or what do we want to achieve? We have already agreed that when this coil terminal is energized, this 13 and 14, which is normally open, will turn to normally close, thereby switching off our generator. How? From the illustration I gave on the board, I said when our two wires of our generators are placed together, it turns off the generator. When they are removed, they allow the generator to turn on. Do we understand? So what happens is that when this contactor 1 comes on, this turns to normally close and then stops our generator from being on. Let me show us a typical example. If we Let me show us a typical example. From my meter is on auto, but I want to read continuity. When I place my wire here, when I place my probe here and place another probe here, you can see that it's not reading continuity. It's not reading continuity. It's not reading continuity. But when the coil terminal of this contactor 1 is being energized, let's see, it's going to start reading continuity. This is being energized. You will see it's showing continuity and it's shouting that there is continuity. So by so doing, this is actually what will turn our generator off because it has closed the switch which was initially open. So this is how to turn off generator using an automatic changeover that can switch in between two sources of power with two contactors, one relay and one breaker. So you can turn off your generator and as well you can turn on, but to turn on, we have to cover that in our next episode. So this is actually how to build an automatic changeover using two contactors to turn off your generator. I hope this helped. See you in the next video.